we would like to determine the algebraic model that created this graph. In order to determine the algebraic model, we need to be very familiar with the base cosine function. Let's look at the cosine function. Here we have our basic cos function. Notice that there are some key points that we should be familiar with. Let's focus on just one cycle from 0 to 360 degrees. There are 5 key points that we want to be familiar with. The first, the maximum at 0 degrees 1. Notice that the function ends at that point. So the end of the cycle at 360 degrees finishes at 1. The minimum is halfway in between the beginning and end of our cycle. The minimum is at 180 degrees, -1. Lastly, there are 2 intercepts. Those intercepts occur halfway between the beginning and the midpoint, and between the midpoint and the end. The intercepts are at 90 degrees 0 and 270 degrees 0. We want to be familiar with this basic pattern for the cos function so that we can sketch cos functions but also read cos functions. Let's return to the graph that we're trying to determine the algebraic model for. In order to determine the algebraic model for this graph, we want to be able to pick out the shape of that cosine function. So where do we see it on this graph? It actually occurs in more than one location. That's why it's a periodic function. It repeats over a certain amount of time, or a certain amount of degrees. One possible beginning point for the cosine cycle is here. This could be the beginning of our cycle. Now remember, the cycle ends at the same location, so 360 degrees, I would be back at this point. Now that is somewhere out of the graphing window. The minimum would be halfway between the beginning and the end. The minimum looks like it's right here. And our 2 zeros were halfway between the beginning and the midpoint, and between the midpoint and the end. So this is probably where our midpoints are. So what is the transformation that moved our cos function from where we are used to seeing it without any transformations to this location? So our usual starting point is 0, 1. So let's draw that. This is the usual starting point for our cosine function. We can see that if it ended up here, we must have gone over this much to the right. Let's read our scale. That's 30 and then 60 degrees to the right. And then it went up 1 and then 2 units on our vertical axis. So we've gone 30 degrees to the right and 2 units up. So our function would be f of x is equal to cos x minus 30 degrees plus 2. There is actually more than one answer. Let's imagine that the beginning of the function was in a different location. The beginning of the function could also have occurred here and ended right here. The minimum occurs here. So Our usual starting point, which is at 0, 1 for cosine, has been shifted to the left, as you could see, 300 degrees. And it's still been shifted up too. So another possible answer could be f of x is equal to cos x plus 300 degrees. Again, it's been shifted to the left 300 degrees. And the vertical transformation is the same. It's been shifted up 2 units. If we want to check to see if our answer is right, we can graph both of these. Let's go to Desmos and graph them and see how well we've done. We're going to graph our two answers and see if they do in fact create the graphical model that we're trying to create. One of the answers was cos x minus 60 plus 2, and you can see we have the graph that we want. But there is a second possible answer. We said that the answer could have been x plus 300, also plus 2. And you can see that that graph sits right on top of the other one. So there's more than one possible answer that we could use to model the graph of that function.